As economists, we want to understand the behavior of production, and we come up with models, statistical models or mathematical models, functions. And production function basically characterizes inputs and outputs, or makes the output as a function of inputs, some sort of inputs. And for production, physical production, inputs are raw materials. And oftentimes we call them labor and capital. We input or put to use labor and capital to produce an output. And in different books you have different concepts, the terminologies or variations of these inputs. And they could be factors of production, or they could also be named resources. They are all factors of production. They are factors that we use, resources that we use, inputs that we use to produce a unit of output. Graphical explanation of a production function or production process. In goes inputs, out comes cars, houses, and everything. So land is input into production, especially land is used to grow agricultural products. Land is used to grow, to build houses. Yeah, land is used to extract gold, oil. Labor basically is people. Yeah, labor is are people. Let's say. Capital is anything that's fixed in the short run. I'll define this later. So in this room, apart from myself and yourselves, everything else is capital. You are, let's say, customers. You're gaining education. You're getting education from me. I'm teaching you. I'm providing you education service. I'm a labor. And everything else you see here is a capital of this business, of this university. In a way, it's a business, isn't it? It's charging you for the products or services we're providing. Similarly, your laptops are your fixed capital you're using to learn. And entrepreneurship, usually these are ideas. You know, entrepreneurs are usually these sort of business geeks, business professionals. Entrepreneurs are the innovators. They come up with ideas, they put them into use, and they make money. So entrepreneurship is just sort of set of ideas in this case that we put technology, let's say, put into use in production. Yeah, right. So that describes the analysis of introduction to analysis of production. Now, before we start analyzing the production in short run, we need to look at some definitions. So total product is output, total output. That shouldn't be confusing. But average product is just basically output per unit, or produced per unit of variable input, I should say. Sorry, it's the average. Sorry, it's the output on average of a variable input. It's the output on average of the variable input. A variable input is usually labor. So you can think of it as output per person employed. A marginal product is then the increase in output from an additional input. So the marginal means extra output from an additional input. Variable input can be anything, but labor is a major one, because as you increase the output, you want to increase, or you usually employ more people. So as a result, a variable input is considered as labor, major input. But it could be, variable input could be an oil used in the production, or rubber used in the production of, let's say, your laptops or your tablets or anything that is made of rubber. Yeah? While marginal product is just basically extra output from an additional input. It's just the output of the next person added to produce the in the production of this good, let's say. Right. So further definitions, and we usually analyze the production in the short run and in the long run, and there's a reason for that in a minute. You will see, because we want to analyze the behavior of production. What happens? Let's say a demand, let's say, for Subway products increases, let's say, suddenly. What can we do in the short run? Short run for a firm could be any time period in which at least one factor of production is fixed. For the Subway company, or that branch there, the factors of production include labor, sandwich artists, and capital. The building, the machines they use, the system they use, the heating, let's say the oven they use to heat and serve the goods or sandwiches they sell. So in the short run, at least one of the factors of production is fixed, which means we cannot change. We can do something with variable factors of production. We can increase or decrease the variable factor of production. But in the short run, we cannot change the fixed factors of production. And in the long run, however, we can change all the factors of production. Now, short run, there is no specific short run period for industries. The time changes from industry to industry, market to market. For, let's say, for a university, the short run could be 3 years. In order to increase the output, in order to increase the admission, let's say, number of students we graduate, let's say, every year, we would need additional capital. That's in the form of buildings, lecture halls, let's say, yeah? So it may take 3 years to build the next building. So that's the short run for us, 3 years. For an oil company, to increase output in the short run, they may need additional oil extraction unit. That could take 5 years to build, after which then production increases. For Boeing company, let's say, to increase output, they may need a new facility, new warehouse, new manufacturing, let's say, facility. It may take 10 years to build it. Yeah? But for sandwich companies or restaurants, it may be a couple of weeks to increase output, because they could rent the next building, next room, or the next building, or expand the space they are in within a week or 2 weeks by hiring, let's say, builders who would then redesign the space, let's say, and then make more space for the people who stay on the queue, and also make more space for the variable input, labor. Yeah? So short run and long run can change from industry to industry. There is no specific time limit. It only depends on the behavior of the fixed input. How long it would take to convert a fixed input to a variable input defines where the boundaries between short run and long run are. Yeah? And another concept we look at is law of diminishing marginal returns. In the short run, because at least one of the factors is fixed, let's say capital unit is fixed, in the short run, marginal product of labor will start decreasing at some point. Now I will show you how this applies in practice. So that's law of diminishing marginal returns. Let me show you what it is here. So ignore these points. A, B, C, D are actually points on the graph that must be in the next slide. Now, number of workers here is the variable input. When we have 0 workers, total product is 0, total production is 0, so nothing takes place. We may have capital input, but someone needs to operate the input. Yeah? Capital stock needs to be operated, so 0. There is no average product as a result, and no marginal product. So you have total product column, average product column, and marginal product column. Next, we hire one worker, using the capital stock, whatever available in the sandwich room in that restaurant. They produce 3 units of output, and their average product is basically 3/1, which is basically total product over the number of variable inputs employed. It's 3. And marginal product, as you can see, when we employed 1 unit of labor, so when we moved from 0 to 1, is 3 units of output. So change in total product is 3 over change in labor is 1. Now moving on, now we employed the second person. Now there are 2 people. Together they produce 10 units. Notice this. There's a big jump from 3 to 10. So 7 extra units. In other words, marginal product of the next person we employed is 7. Yeah, alone, a single worker was making only 3 sandwiches. But together they make 10 sandwiches, let's say, within an hour. Now average product is basically 10 over 2. It's the productivity. So each of them making 5 sandwiches per time period. Now we employ next person. 3 people now together make 24 sandwiches. On average, each one makes 8 sandwiches. And between 2 and 3 people, when we move from 2 to 3 units of labor, we now have an additional output of 14 units. So you see the jumps, 3 to 7, 7 to 14. So as we added more labor, but we only have a fixed capital, that space there in the Mile End area, the subway. But notice what happens. As we add more labor to the existing capital stock, our marginal product initially increases, but starts decreasing. Why do you think that happens? You see, marginal product of additional work is now increasing, but then after the third person, it starts decreasing. So the fifth person adds only 4 sandwiches, produces only 4 sandwiches, while the third person produces 14 sandwiches extra. So together 4 people produce 14 more sandwiches. 3 people produce 14 more sandwiches. Now question is, why this is happening? Why the marginal product is decreasing? Increased, but then decreased. That's long run concept though. About the costs. Yes, go on.
It's too busy in the workspace.
Exactly, in the workspace. It's too busy. Workspace was fixed, wasn't it? Remember? We only have 1 oven, 1 fridge, a few bits and pieces there. But then we now have crowded space. They are getting into each other's way. They are just distracting each other. One of them is just sitting for coffee, doing nothing, because it's already crowded. What should I do there? Yeah. So as the production is fixed, capital is fixed. Sorry, as the capital is fixed, but we're bringing in more labor, which means then, given the small space now, output now starts decreasing from additional labor. Each additional labor now starts producing less. Makes sense now? It's like you have a plot of land, you want to cultivate it. With 1 tractor you can cultivate it in 1 hour. With 2 tractors you can cultivate it in 2 hours. As you add more tractors, they cannot move at all then. Yeah, land gets crowded for the space, So tractor here being variable input. So that's the idea. Now, we will now show this in a graph. Exactly the same thing, number of workers, total product. You can see this now. With 1 person, we have 3 units. 2 people, we have, if I remember, 10, yeah? Okay, it's there, by the way. 10 units. And as we add more people, we are jumping from this small initial output to a higher output and making an even higher jump. This is leapfrogging higher. And then we started now jumping, but not as high as we did before. So this jump from 3 to 4 is shorter. So output now is increasing, but at a diminishing rate. Diminishing marginal returns set in somewhere here apparently. After the third person, our jump from this point to this point is basically smaller. And it gets smaller, smaller, and smaller, and even declines eventually because of the overcrowding. Yeah? Makes sense, guys? This is the law of diminishing returns in a graphical form. So diminishing returns kick in somewhere here. You see that between points, the length here is longer, yeah? Space here is longer. The distance here, I should say, shorter now, shorter, and even negative, yeah? As we add no more workers, our sandwich production per hour starts diminishing. So the sandwich production increases, but at a diminishing rate. Moving on now. By the way, there's this maximum production here. So cost functions. Where there is a production, there is always cost. Definitions. Standard variables in the short run. Cost function. Quantity is just the output, number of products produced. Fixed costs are just costs associated with fixed inputs, let's say capital. We usually lease the capital and we pay periodic costs. Regardless of how many units we produce, we pay the same amount of cost. The same amount of expenditure every year, every month maybe. So it could be rent, lease, line rentals, some other, let's say broadband expenses, so on and so forth, so for a business. Total variable costs are basically variable costs, costs that vary with the level of output, or as we produce more, we employ more workers, so our wages increase, wage cost increases, labor cost increases, or raw material costs increase, so it's the costs that rise with the output. Now total cost is then obviously fixed cost plus variable cost. Total cost, TC, is TFC, total fixed cost, and total variable cost. So I'm going to move on now, if everyone is happy with that definition, no questions. So this is the behavior of costs now. The green line here is flat. Green line here is flat is because it's fixed cost. No matter how many units of output we produce, the cost remains the same. We still have to pay this, let's say, insurance company, the bills, utility bills, assuming that we use exactly or more or less the same amount of electricity and heating, let's say. Yeah? So they are fixed. Or the rent, for example, it's always the same unless there is a change. But that doesn't associate with the level of output. Yeah? If your rent changes, then it's not because your production increases, just because the owner of the building warehouse may have increased the cost, yeah? Increased the rent, yeah? So total fixed cost is fixed, was constant at any level of output. But look what it is. Total cost is starting at this point and increasing. And parallel to that increases the total variable cost. You could see that the shape of total cost is determined by the shape of variable cost. That makes sense, right? Because fixed cost is fixed, it doesn't change. Even if you produce 2 units, you pay the same amount, but you're paying higher variable cost. When you produce 3 units, you're paying higher variable cost, but fixed cost here is the same again. Yeah? So this cost plus this cost here gives us total cost here, right? Makes sense? So moving on now. Now, again, behavior, look at the behavior. It's rising initially. The marginal cost between these 2 points is low, but suddenly there's a steep increase in marginal cost. So costs start accelerating. That's because, again, there is a diminishing marginal returns to additional input. In other words, with the additional labor, we are not producing as much as we used to produce before. So output is smaller than the cost that we are paying. That's why this happens. There's an inflection point. So if there is a mathematician, do you know this? Yeah, inflection points. This steep increase then kicks in because of diminishing marginal returns to variable input. So that's just a description of what I've just said. So this inflection point means diminishing marginal returns to variable input is now kicking in. In other words, from this point onwards, additional costs are higher relative to the production. So we're growing, our costs are growing faster than the production per unit. Yeah? Now, costs and their definitions and formulas. Average fixed cost is basically TFC over quantity of output produced, total fixed cost over quantity of output produced. Notice this, total fixed cost may not change, but average fixed cost changes. So I'll show you in a minute, because, you know, the fixed cost now, let's say 100 pounds. It won't change no matter how many units you produce. But it will change if it's average fixed cost. Because as we produce more, by dividing the fixed value by a varying value, basically you are varying the average value per unit cost as a result. Average variable cost is just the variable cost per unit. It could be wages per person. It could be, let's say, tomatoes per sandwich produced. Yeah? It could be any other variable costs that change with the number of sandwiches we produce. So cost of tomatoes per sandwich produced is this one, let's say. Now, it also changes, obviously. Further definitions. So the average cost as a result is basically total cost over output. It's basically average fixed cost plus average variable cost. Then the marginal cost is the change in firm's total cost resulting from a unit change in output. So each additional unit incurs additional costs. So that's what the marginal cost is. Marginal product is the change in output from a unit increase in labor, let's say, which was the variable input, yeah, in the short run. In this case, this is the quantity of output. Yeah, the quantity of output. Change in Q is quantity of output. In the marginal product case, it was the quantity of labor. Yeah, so this is the difference here between the cost and product. Marginal product and marginal costs are differ. One takes into account costs. One is about the production. Yeah. Now, moving on to the next slide to explain you these concepts in detail. Output Q units is basically total output produced from 0 to 1 to 3 up to 7. Let's say these are sandwiches. Let's say total fixed cost is fixed. As you can see, it's flat out 12 pounds per, let's say, whatever time horizon, let's say per hour, per week. Average fixed cost is basically total fixed cost over Q, so that over that. Obviously we don't divide numbers by 0, so that's not defined. Total variable cost is basically variable cost over quantity. Sorry, this is total variable cost. Apologies, I'm defining the average fixed cost. This is the sum of the variable costs. Average variable cost is the total variable cost over quantity of output. Total cost is then the sum of the two. So these columns, this plus this. Total fixed cost plus total variable cost. And then you have average cost, which is basically total cost over quantity. The marginal cost is the change in total cost over change in quantity. With this idea of marginal cost decreasing initially and increasing eventually. So if we produce the first unit, the total fixed cost is still the same. Whether we produce or not, we pay the same rent amount, rent payment, yeah? Average fixed cost is then obviously total fixed cost over 1, gives us 12 units. Total variable cost of that first unit is 10 pounds. Average fixed variable cost is then the 10 over 1, that gives us this. And notice again, total average variable cost also initially higher, but it declines, but then bottoms out and starts increasing, yeah? As does MC. In fact, MC is what's actually affecting this variable cost behavior, average variable cost behavior. Now, total cost is basically increasing as we produce more and more output. It's the sum of total fixed cost and total variable cost. Average cost is ratio of total cost and then the output. Now, look at the behavior of the marginal cost here. 10 units, when we 10 pounds, when we produce the first unit, our total cost increased by, so this one here, yeah, increased by 10 pounds. 22 minus 12 is 10 pounds increase from the original condition, yeah, initial state. Now, if we produce the second unit, our marginal cost is now lower. So the total cost now is 28. So difference between them is basically 6. Marginal cost is lower. So in other words, we added that next person in. We basically hired that next person to work in sandwich production unit, let's say, and that person produced more than he costs to hire, let's say, or she costs to hire. So if you divide the cost by the output they produce, you get smaller output. But notice that as we add more and more people, remember what happens? Overcrowding happens, and each additional unit each additional person will add less output. They produce less. But then their wages are high. It didn't change. We're still paying the same wage as before. So if you divide an increasing wage by decreasing output, what happens? You will have increasing marginal cost. Yeah? So initially we have efficiency in our production, our marginal cost decreases, but eventually, due to diminishing marginal returns, our costs now increase. Because in the short run, we are only able to change variable inputs. We're trying to increase the output, but given the fixed capital, we hit this point where each additional sandwich artist produces less and less than previous additional sandwich artists, yeah? Previous additions to our labor force. So less production, more costs. Total cost now increasing, production is increasing but at a lower rate. If you divide by total cost by the diminishing output, you get a higher marginal cost. And similarly, higher average variable cost or higher average cost as well. Now, to demonstrate this further, I'll move on to the graphical explanation here. So these are the costs on the y-axis, these are the output on the x-axis. So notice this marginal cost. Ignore the others for now, the red line here. It's decreasing, which is a good news, but starts increasing from point onwards x. So as we produce more, our costs are declining. That makes sense. as we add more people, we are able to produce more given the fixed input. But at some point, costs start increasing. Again, this is because of diminishing marginal returns to fixed inputs. Because our capital stock is fixed. And we are adding more people means we are increasing the variable costs, which adds to the total cost. And total cost is also increasing. Relative to the output now, total cost is running faster. So if you divide something that's running faster than divide something running faster by something that's running slower, increasing slower, then you get a higher value. So the output now is, or the marginal cost is now increasing as a result. In this region, however, marginal cost is decreasing because relative to the wages, the output is running faster here. Output is increasing faster, let's call it that way, if it's easy. So it reduces, as a result, our marginal cost. Then this actually determines average variable cost behavior as well. So green line here, average variable cost does the same thing. It declines for a moment and then starts increasing. And since average cost is affected by average variable cost is also U-shaped. So these three now are more or less U-shaped. Marginal cost, and average variable cost. In the book, Mankiw defines marginal cost as a straight line, although then he moves on to a section where he tells, in general, marginal cost is more or less J-shaped. So he mentions this as well, yeah? If you understand it as a straight line, keep it as a straight line, but the behavior of marginal cost is actually, in general, J-shaped, while the other two are more or less U-shaped. And notice this average fixed cost now is declining. It's asymptotically declines and it approaches the x-axis as the production goes to infinity. So that means as fixed costs were fixed, remember? And average fixed cost was total fixed cost over quantity. So the total fixed cost is fixed. It doesn't change. But our quantities are changing. So as we divide the total fixed cost by a larger quantity, per unit cost is now declining. Yeah, that's the idea here. So average fixed cost is declining and declining. And notice this. The distance between, so this distance is basically, this distance between AFC and x-axis is the same as this distance here for this output. So as the average fixed cost declines and approaches the x-axis, average variable cost approaches the average cost as well. Yeah. In the end, these two actually comes close to each other, this average cost and average variable cost, because average fixed cost approaches the zero value. Yeah. As we produce more, the fixed amount of cost is spread over many units. That reduces the fixed cost to almost zero. So let's move on. There's a nice relationship between costs. So what we observed so far was that average fixed cost declines steadily as the output increases. So on the y-axis you have costs, on the x-axis you have output. It's the same graph as before, but in a smaller scale. Second observation is that when the MC, marginal cost, is equal to average variable cost, average variable cost is at its minimum. So the same true to average cost. Basically, marginal cost cuts through the average variable cost and average cost at their minimum points. And in general, this is what happens in businesses, but businesses will not have time or resources to actually analyze their costs, and they probably make a lot of mistakes. So economic consultants will probably do this. If you're an economic consultant, at some point you may use this in an Excel spreadsheet, these ideas, and work out the minimum point for a company's average cost, let's say, in the short run. Yeah? So when marginal cost is less than average variable cost, notice this. When the marginal cost is below average variable cost, so below the green line, if the red line is below the green line, what happens? Average variable cost is falling. But as soon as marginal cost is above the green line, this red line is above the green line for a given output level, our average variable cost starts increasing. Yeah? Keep that in mind. And so we've just discussed that point. When marginal cost is above, average variable cost starts increasing. So it's basically the same for average cost, and we will try to discuss the rationale behind this idea in the seminar. So I'm going to defer that to the seminars given the time constraint. Now, that was a short-run behavior of cost curves. What happens in the long run? It's a different scenario now, guys. It's a different setting. in the long run, as you remember, everything is variable. Yeah, there is no fixed input, and long run could also be any time, as long as everything is variable. So in the long run, we can build our new buildings, we can hire new equipment, and there is no fixed input as a result. Now in the long run, because scale of business changes, what matters for the costs is, or the output also, is the scale of output or scale of production rather than the marginal returns. You remember in the short run, where the behavior of production changes was the marginal return, or marginal cost, inflection in the marginal cost, and also inflection point in the marginal production, marginal product curves. So it's the scale, returns to scale, that's a new concept now that we look at today, not the marginal returns to variable inputs in the short run. Now, let's describe the short run and long run in an example. What's this? Input 1 is fixed. So this is capital. We have 3 units of it. Input 2 is variable. Yeah? We are adding more and more to 3 machines, let's say. As we add, so with 3 machines and 1 labor, we have 25 output. With 3 machines and 2 labor, we have 45 output. So this is 20 units of increase here, yeah? 20 units increase. So there's a marginal product of this additional person is 20 units. With the where fixed input is still fixed, we add the third person. Together, these 3 people and 3 machines produce 60 outputs. So that's a 15 output jump here. Increase in output is 15. But now, given the 3 factors, fixed factors, we added the next person. 4 people now produce only 70 units. So the jump here between this point and this point is basically 10 outputs. And then you can see that marginal product is even less when we added the 5th person. So 5 people, 3 machines, less efficient, and they only produce 75 units. Now, in the long run, however, notice that there is no fixed input. For each person, now we have 1 machine. So 1 machine, 1 input, produces 15 units. This guy was able to operate 3 machines here in the short run and produce 25 units. So they can actually run between the machines, right? But here is only 1 machine and 1 person. So that makes sense, 15 units. It's less output. But then when we added the second person, 2 of them operating 3 machines, they could produce more. But notice here, with the long run now, as we increase the fixed input now, alongside the variable input, our scale is different now. We have 90 units now when we have 4 people and 4 machines, while 4 people with 3 machines were only able to produce 70 units. Can you see that? There's a scale changing now. With the input, this first input being now variable, our scale of output is completely different. Starting point is 15. Here starting point is 25. So this is a completely different output curve now. Yeah, so it's the returns to scale now. As we increase the inputs together, we have even greater output here. So there's a different scale now. The idea is that the returns to scale now is an important factor here, because we don't face in the long run diminishing returns to additional variable input anymore. So we will now express this in terms of this economies of scale ideas. In the long run, we can increase our output, but then we also have to look at the cost side. Economies of scale is inherently associated with average costs. Now, costs per unit, in other words. As we produce more, you know that our cost per unit reduces, declines. That's why we say bigger firms can produce at lower costs. They produce cheaper because they're big. They can spread the cost over many units relative to the small firms which produce at higher cost because they don't produce more. Their scale is small. So economies of scale means savings from increasing the scale, savings from being bigger. You know the guy, famous restaurateur, or the chef, famous chef, he had 12 restaurant chains, branches. And recently he had to close 11 of them and hold on to only 1. When he was asked why this happened, he said initially we planned to take advantage of economies of scale, which meant we wanted to open more stores so that we can reduce our average cost, sell more. Because with one restaurant, the expenses are huge and you can only have a smaller number of customers in there. But as you open more restaurants, you could have more customers, greater varieties, and you are larger relative to before what you were, yeah? So you can now negotiate cheaper variable inputs now. So your average cost declines per unit meal you produce as a result, yeah? You can cater greater number of people now at lower costs. So he said, we were trying to take advantage of economies of scale, but then we opened the branches in wrong places and economy wasn't doing well and there was competitors, so on and so forth. It goes on. Right? So economies of scale is basically a long-run phenomenon. In the long run, the idea here is that as we produce more, we reduce the costs. So this could be due to specialization and division of labor. Larger firms can split the jobs. You know, if you go to a sandwich artist there, one person does cutting the bread, putting the stuff in there, putting it in the oven, doing the cashier's job. But if you add more and more, what happens in the long run? One person cuts the bread, another one stuffs the bread, another one puts it into the oven, another one just takes the money out. So that's more efficient, they produce more, right? So that's the idea here. As you increase the output or become larger, you could obviously employ more people with alongside more capital, of course, then your costs are lower. So these are basically other reasons I'm going to skip now. But then there is also something called diseconomies of scale. Diseconomies of scale is when you hit the point where your costs are actually increasing now instead of decreasing as you become larger firm. That's why a lot of firms tend to scale back by cutting out, what you call this, by making redundancies. Just this morning I read, I watched on Sky News that HSBC is making redundant 25,000 employees, and mostly from investment banking division. It's become so large, the per unit cost is now, or per service provided cost is now so large as well. So they said, okay, we are operating at a higher level, so we need to put it back. We need to come back, scale down basically, yeah? So here it is, here's the idea here. So HSBC ended up being here. When it was a small company, it's increased its scale because it had more customers. So their average cost, so this is average cost, declined. It bottomed out. No matter how much they produce in this region, it's the same cost per unit now. But HSBC ended up being here and says, okay, this is too much. It just reduces our profit. So why don't we go back and, let's say, reduce 35,000 workforce by 35,000, and then we produce a little less, but we are at a lower cost, yeah? Per unit now is lower here than there, yeah? Larger means lower per unit cost, but it doesn't mean infinitely lower, yeah? At some point, you will face problems such as this. Managerial complexity. You have lots of layers of managers who are earning hundreds of thousands of pounds a year doing nothing, basically. Or alienation. Alienation is just even it happens in small firms, but when it's larger, workers don't get their voice across the board at all. Or industrial relations problem, too many people, too many problems like in this university. Yeah? We have trade unions now calling for protests. Yeah? These cancellations of lectures. This is going to be costly for the university. So there's space, interval between which costs are at the lowest and there's no change in costs, no matter how much you increase the output. But at some point, these economies of scale kick in because of all the long-run problems firms face. So economies of scale can be internal or external. Now, internal ones are due to firm being larger. External ones are due to industry being larger. Large industries means you can connect with others and reduce your work with other firms and reduce your costs.